It is my duty to bid you all a genial welcome. I'm Samita Mishra and I'm currently pursuing my class 10 in Delhi Public School Sector 14 Rourkela. Today I take pleasure to introduce you all to my project. The project name is Pneumonia Detection by the help of Chest Express. So let us have a look at my project.
So everyone, welcome back to my project. This is my project which I created in Jupyter Notebook, and as pneumonia is a very common problem and it is very dangerous disease, so let us help people and doctor to find out the pneumonia and let's save our youth. So let us go with the code. So the first, we have imported the library, so far our file can support our code. And second, we have created the folder directory and the category for the subfolders that it can detect the actual path. This is the folder path and this is the subfolders in it which we have saved our data. And thirdly, this is to get the picture from the folder by using for loop. So this is specially called the image rendering. And next, our step to the length of data. So length of data, here we are defining the length of data we have taken. And next, this is import random and for the rendering of the image. And next, this is the x and y, the two variables to save our data in that. And next, we have an array to save our files, and pickle to save our folders and everything, and x to give a shape and size to our image. And this is my model 1. This is a test. This is a training model. And coming back to the part 2 of image processing, that is for the second model for the testing phase. So I have another one. So here it is same. Firstly, we have taken the import library, so far it can support our file paths. And next I have taken directory and category for the folder link and the subfolders. And thirdly, it is a image rendering and length of data. It is pretty same in every case. And next we have length of the data, and this is for rendering, import random, and x underscore y test for the normal and y for the pneumonia detection, the two variables. And next we have test array of x and y for the test, so that it can actually detect the normal and pneumonia folder. And then we have a file shape or image shape, we can say. And moving to the next model, that is we have from import pickle, so that because it can transform a complex object into a byte stream. And next we have two variables, that is x and y. It is for model rendering, it is specially for model rendering. I have divided it by 255 for the very good pixel quality. And next is that x shape for our image. And next I am moving on to the model rendering, and this is from Keras.models. The import sequential, import concv2d, max pooling, flatten and dense for the supporting the files. And this is the model sequential and all the rendering of the model. And coming to the optimizing and the compiling and splitting of the model, we have this code. And to predict the loss and the correct metrics accuracy. And coming to next, you have already created the accuracy level and given our input data. And next we have the skitlearn metrics to import confusion metrics and classification report. We have done it in the NumPy, so far it can actually predict the images. And then we have the classification of the images, and we have the accuracy and F1 score.